Hello, today we'll be discussing the importance of vegetation monitoring. Vegetation monitoring is a recurring annual census that surveys the growth of diverse trees and lianas found in tropical forests. The Team Vegetation Protocol is used to standardize vegetation monitoring. It provides exact guidelines to ensure that each data collection is faultless. The Team Vegetation Protocol aims to identify at least a 1% change in above ground carbon. Thus, it does not monitor the minor growths of roots and seedlings. Establishing your plot, there are a few steps that need to be taken before the first census can begin.
The first step is submitting a sampling design proposal to the team technical director. Once this is approved, you can start the reconnaissance of the plot locations and corner placements. This involves establishing the plot locations and their current conditions using mapping equipment such as a Geographical Information System software package. If the plot placement is not satisfactory, a shapefile has to be resubmitted. Once locations are approved, the establishment crew has to be assembled and trained. Training is not limited to but includes reading a compass and using a clinometer. Plots can now be established in the field, and final coordinates of the plot corners, bearings, 20 x 20 meter subplot numbers can be submitted. A vegetation census crew needs to be assembled and trained and are selected by the site manager. Technicians include a diameter taker in charge of measuring, note taker for writing down information, and the painter who marks and paints the trees. Most important step is measuring the two 100 meter baselines and ensuring that they are perpendicular to each other. Medium fixed string is used for the perimeter. Once baselines are complete, 11 100 meter perpendicular lines are measured in between the two baselines, and a thinner string is used to mark these edges of the subplots. Thus, a 1 to 2 centimeter error per 100 meters is allowed when establishing the 1 hectare plot. Kilometers are used when the plots are on a slope. This ensures that a 1 hectare plot is planar. Another problem that could occur is how to judge when a tree is inside or outside the plot. If more than 50% of the tree is in the plot, then it is included in that particular subplot or plot.
The first census can begin once all of the standards of the protocol for establishing a plot have been approved. Vegetation plots have to be censored in the dry season of the region and measured during a 4 to 5 week period. The recensus for the following years must occur at the same time at each year at each team site. Firstly, all of the equipment needs to be collected, but the most important are the calibrated diameter tapes. The diameter tape can be easily stretched, therefore it needs to be calibrated before it can be used.
300 mm of diameter tape is measured against a 1 meter aluminium rod. If the reading of the tape is equal to or greater than 945 mm, the tape needs to be replaced.
This procedure needs to be completed for every diameter tape at the beginning of every plot.
The first census can now begin by going to the first plot. As you can see from this figure, subplots need to be measured and staked. For example, the first plot's corner stakes are at 00, 020, 2020 and 20. This is classified as a quadroot. The same process is used for the other 24 subplots. The stems of all trees, lianas, palms and tree ferns that have a breast height greater than 10 centimeters have to be measured. All trees are different. Therefore, each species or problem tree requires a different approach for being measured.
I will now demonstrate how to measure a normal tree. Firstly, we place the 1.3 meter rod against the tree, making sure that there's no moss or bark in the way of this. I will now grab my diameter tape and place it around the tree.
When marking the reading of a diameter tape at the 1.3 meters, ensure that it is not twisted and that the diameter tape is perpendicular to the main axis of the trunk. The reading of the diameter tape should be where the number passes over the 0 centimeter line, recording the diameter to the nearest millimeter. Marking the point of measurement is now done using a crayon and then painted with an exterior emulsion paint using a stencil to ensure no measurement errors. The tree can now be tagged with the nail hammered on a downward angle, leaving room for future growth.
Now the X and Y coordinates need to be recorded. Stand at the stake in the center of any given subplot, identify all the stems visible from this point, using a 50 meter tape measure and a clinometer to measure the distance, and take the bearing of these points using a sighting compass. Do this for every plot until you are done processing. Once this has been completed, transcribe all of the data to a Team Excel template and upload the data to the Team Data Repository. Now it's time to recensus the plots. Vegetation plots have to be recensored during the dry period at the same time as the first census. This process has to occur every year. The recensus follows a similar procedure as the first census. All of the stems that were marked and tagged need to be remeasured, and any new stems have to be identified, marked, painted, tagged, and their location recorded. Before the recensus can begin, a pre-census measurement error estimation needs to occur. This certifies that the data can be compared with previous census. If the measurement error of the diameter tape is not acceptable, the technician will need to be retrained until it falls within the acceptable levels. Once the measurement error of the diameter taker complies with the standards required by the protocol, the recensus can begin. Vegetation monitoring is important for observing climate change in relation to the growth, function, mortality, and species heterogeneity in tropical forests. forest. However, major weaknesses in this protocol occur. Every year a recensus is conducted and either new technicians or already trained technicians are assembled. The techniques used by these technicians may vary, thus the data collected could have mistakes. These mistakes might seem minor, but they have a substantial effect on the overall data. For example, using the diameter tape the wrong way due to the tape not being perpendicular. Consequently, having well-trained technicians allows quantification of the standardized data that can be used as a credible source for records. If the protocol is followed precisely by technicians every year, then the data collected can be utilized effectively to monitor how climate affects the growth of tropical trees, ferns, and lianas.